So problem number 8 of the MIT integration book of exam 17, which is a definite integral from x tending to negative infinity to x tending to positive infinity of e to the power negative 2x squared minus 5x minus 3. This is actually a very interesting problem, and let's see how we may be able to solve it. So this is our problem, right? This is a tricky problem, but it assumes that you know the Gaussian integral, which is the integration from negative infinity, from x tending to negative infinity to x tending to positive infinity of e to the power negative x squared is equal to the square root of pi. This is going to be our basis or our axiom, the assumption that we know that. And for those of us who don't know the Gaussian, the bell curve, right? Y equals to, right? So the area under here is square root of pi. So what we'll do here is, one, we will pull the 2 out so that we are left with x squared plus 5x over 2 here, 5 over 2x plus 3 over 2 inside the brackets. And then we are going to do something else. So 2 inside the bracket, we can express this part x squared plus 5 over 2x as x plus 5 over 4 squared minus 25 over 16 plus 3 over 2. Okay, and that becomes e times 2 x plus 5 over 4 squared, common denominator 16, negative 25, 16 divided by 2 is 8, 8 times 3 is 24, so negative 25 plus 24 is 1. Okay, so we've come to a point where our problem is e 2x plus 5 over 4 squared minus 1 over 16. We can pull this out, so negative 2 times negative 16, it becomes x plus 5 over 4 squared, close that bracket, and then we have e to the power 1 over 8. And this has come from us multiplying negative 2 times negative 1 over 16. We can pull this out so that we have e 1 over 8, negative infinity there, 2, then become 2 there. Okay, so our problem is actually evolving pretty well. So we have e to the power 1 over 8, negative infinity, negative 2 x plus 5 over 4 squared. We can say let u be equal to x 4, so that du dx is equals to 1, and that means we can substitute for dx with just du, and the limits will remain as they are. So we have e to the power 1 over 8, negative infinity, e negative 2u squared du. Dx and du will just substitute for dx with du. So e to the power 1 over 8, negative infinity to infinity, squared du, which becomes 1 over 8 e negative root 2 u squared du. We can say, okay, let y be equal to root 2 u, which means dy du is equals to root 2, and so we can say 1 over root 2 dy can be used to substitute of du. And then the limits still remain. Just a factor of root 2 won't change the limits. So we have our problem that is e root 2u squared du. This is equals to now e 1 over 8 e minus y squared dy over root 2. So we have e 1 over 8 over root 2 being equal to e y squared. Okay, now we've come back. This here is our Gaussian integral, right? What we had initially said it's equals to root of pi. So what that means is that our integral is 1 over 18 root 2 times root pi, which is the same as 1 over 18 square root of pi over square root of 2. And this here is the answer for the integral, or from x tending to negative infinity to x tending to positive infinity, of e to the power 2x squared minus 5x minus 3. So that, ladies and gentlemen, is our answer. So until next time, bye-bye. It was an absolute pleasure working on this problem with you guys. Bye-bye.